the last stone weight, and we're given an array of stones where the ith stone has a certain weight, and the rule is we take the two heaviest stones that are available to us, we smash them against each other, and the new weight that we get will be the absolute difference in their weights. If both of the weights are the same, the stone just gets destroyed, and we have to keep playing this game until there is at most one stone left, and if there's no stones left, then we return 0. Cool. So to do this, I'm gonna be using Heaps. I guess this is kind of similar to like a sorted container, but it's way lighter than a sorted container. We don't have to actually keep everything sorted with a heap at all times. And what can a heap do? A heap can insert something into that heap in log n time, which is pretty good, and we can get like the minimum or maximum value. So it depends on if it's a max heap or a min heap. I just wrote minimum here because Python, the default behavior is a minimum heap. And if you want to search for value other than the minimum, then it takes n time, which isn't that great. If you have a problem that requires you to search in or log n time, then you're better off using like a better data structure, such as like a AVL tree or similar, or like a sorted container. And when do we use it? When we want to get when we only care about the lowest and the highest values at any given point. We don't want to look through the middle, otherwise it's just too inefficient. So in Python, this is the way to get it. There's a heapq library, and it comes with a heapify method that will heapify a list, a heap push that will add something into that list, and a heap pop that will pretty much it works like a pop. It just gets like the minimum value. Similarly, in C++, it's a priority queue where we can push something in it, pop. We can get top is like the minimum value, and empty is just to check if it's empty. So let's just do this. So first we'll have to, in Python, import heapq. So we import this library here, HQ. I'm not sure if library is the correct word. I'll have to Google that later, but I'll make sure what that word is later. The heapify, and because in Python it's a minimum heap, we might want to just declare the heap as negative s for s in stones. Gonna heapify h. There might be a better way to do this actually, by avoiding this negative operation, because that's like O(n) complexity at the beginning. And next we want to just len of h is more than 1. So there's at least 2 items in here. Then we want to pop them out. So s1 and s2 is dot heap pop. So notice how you have to put the actual list inside heap pop. And then we check if s1 is not equal to s2, then we have to insert it, insert the new stone. And remember that these are negative values. So because they're negative values, the second one will always be small. It'll be smaller in absolute value, but it's like a bigger number in theory, if that makes sense. So we just want to do s1 minus s2, and this will always be a negative number. And yeah, that will just break up the stones. And in the end, we just want to return the last stone if there's only one stone left, if len of h is equal to 1, otherwise it's a 0. I think this is fine. We'll give it a shot. Oops. Yeah, because these were negative numbers, we need to remember to make it negative. Let's just submit it. Cool. So it wasn't amazingly fast. And yeah, let's actually look at heap queue. If it offers like a maximum heap. So apparently there is actually something called heapify max. Okay. That's weird. Let's try this out just for fun. So we use heapify max. We use heap pop max. And in theory, we don't need to do this negation thing anymore. Oops, and h no longer exists, just we're using the stones array directly. So heap pop max exists. Heap push map what? Okay. How do I push though? If I heap replace max. So weird. Let's see. If we can find like interesting. Heap push map. So we can sift down. So we just append s-1 into stones. And then we'll have to call this weird function. Down max. From 0 to the end inclusive. Do you mean help? Weird. So that actually looks like that worked. And we didn't have to negate anything. And it's a lot faster. Yeah, that's quite strange. Yep, so this is an interesting way to do it. I've never used these functions before, but I guess we learned something new today.